Hello.
Good evening, everyone. We maybe just give 1 more minute. So we have a few people here. Oh, a lot. Can you hear me okay?
Yep.
Good, good. Let me share the screen. Share screen. Are you seeing the show mode or the full screen?
Yeah.
Oh, you say full screen. Okay, good.
I should turn mine up to like 9,000.
So we can start, right? Okay, let us start now. Coach David asked me to talk about the how to use the Spike Prime set. So it's a set of the training camp. I think maybe 9 of them. Today, I will talk about go over the camp 1 and camp 2 together. It's starting, so it's pretty basic, but everyone probably already, many people may already know it. So, but I do give you challenges there. If you think it's easy, you can go the challenging ones. Okay, the camera one is the driving around, is how to drive the robot, maybe to avoid obstacles. Camera two is playing with the objects, just the grab, push, the thing. First, there's two resource for the students. I will show you a video from each link, so you will see what that means for drive around, what it means for the play with the objects.
Hey, Charles, this is David. It seems that you are sharing your note screen or presenter view. Is
Oh,
that
presenter view?
something you are intending to do?
No, I should share a different one.
Right, yeah. Maybe you want to switch it up.
Are you seeing?
Yeah, this is the correct view.
Oh, this is not correct. Which one is correct?
The previous one. Now it's
Ah.
showing the presenter view again.
This one is correct, right?
This one is good.
Okay. So for the first one, drive around, we just watch a short video first. You can take a look at what's the key points here. What's the key skills here?
I don't think they can click on the link because it's in presentation mode.
Oh, you cannot see it here? Oh,
Yeah, if
maybe.
you paste the link in the chat, they can click on it.
Oh, I think we need to share the whole computer, not share the screen, right? When's share screen? It's how to share the link. Link is over there. Let me go back to the where's the link? Let me click link. Chat.
Jason,
What's the second one?
I placed out.
I think I need to reshare. Share everything. Share what? Oh, I can share here.
Are we supposed to watch the video right now?
Yeah, it's very quick, just a couple minutes. So I will I can share it to see, so you will see what we need to learn to drive this around. But I'm not sure. Let me just play it. Okay, can you see it now?
Yep. Your first. We can't hear it. You need to like turn on the settings so that we can hear it.
Okay, this is the first one. I think, did you notice what kind of movement the robot makes? Yeah, tomorrow you hands-on, you need to try to
Yeah.
make it move forward, take a turn to avoid obstacles. Probably you need to control the speed, running time, and turn around. So that's the first one, move around. I will go over how you use the code to do that. Okay, then the second one a little bit more challenging here. You will see. You see screen now? Okay. The second one actually you see a lot of need to add another stuff to pull the objects, and also need to detect the and stop the engine, then grab. So that's some sensor, some parts there. Let me go back to the deck. Okay, the training camp is actually about all the components of the robot and learn how to control it. Okay, so this the command one will be the just practice the driving around. There's the blocker script is pretty straightforward. You just move forward, backward, turn. So you will try. I have some homework at the end of the page, so you need to practice maybe doing some code on your computer, bring it to the house tomorrow for the test on the robot. Okay, so tonight I will go over this the basic introduction about the problem set, the how to. I think the robot sabotage you already know how to do it. Here, just very brief there. Then some programming to do the driving, some programming to do the how to play with the objects. What is the Spike Prime? It's just a set, robotics kits. You also use guys see in the first night at the Fifi's house. So that's the one we're using the Spike Prime. Okay, it's used as a FAI challenge competition team. They have the models. Okay, you need to know what's the models, what's the sensors, and this hub. The hub is just like the CPU or the motherboard is the brain of the robot. Then you have models of more the things around. You have
I missed the whole bunch.
No, you didn't. Just dropped. I think Charles just dropped.
What happened? It said the host ended the meeting. That's what it said for mine too. So probably Josh misclicked. Probably.
Yeah. Hopefully can get back. I wonder if he knows it.
Yeah, let me give Charles a call, and I'll be back.
Hello.
Yeah, we can hear you now.
Okay, good.
Yeah, sorry for the technical issue. Yeah, I think you
No
can
problem.
start
I was
on the
able
last
to
slide.
share with a different screen. Let me go to here. Okay, we are in the Spike Prime apps here, so you can see we're using the Prime Spike Prime. That's a little bit more comprehensive than the essential version for the Spike. So let me see. Here is just all the blocks here. You have models, movements, lights, sound. These are different blocks. You do the drag and drop to control the code, the movement of the robot. Okay, let me go through this again. So you typically just use predefined blocks, but it does provide the customized blocks. I'm not sure our FAL need to customize blocks. Probably it helps to customize if you have some set of functions to common functions to use. Probably you can customize a block of our own for the team. For the Kernel 1, the key blocks is these few things: the move steering. You just control movements like forward, backward, this thing, or turn. There's another important thing called tank drive. Just just for names, just drive like a tank. it can move all around. So you have typically you have multiple models. You can control both either model, left or right models. Then you take turns, or you can have very precise control over the model. You have wait block. You can use a time to set how long you wait. You have 10 block rotate by the angle. So when you do the coding, typically you can do a very small, simpler ones, like a 3 to go forward and backward, and 1 turn 90 degrees, and this kind of thing. Okay. But if you remember the first video, they have the obstacles. So that's you need to make a small turn, then move. Those kind of things you need to do it. You may do it afterward, after you already familiar with the simple turn forward stuff in the blocks. This block, I think many people are already familiar with it. But I myself is not very familiar with this block. So you can see there's a start moving block, moving for how what's the direction, and for what's the rotations there. Okay. So this what maybe have forward movement. You can turn the robot, you can stop the robot. Let me see what you have. So for the hands-on practice, you guys will do tomorrow. This first one is drive around. I put a few specific instruction here. So you do drive a robot in a straight line, make turns. Okay. So here you say, okay, you just move forward for 3 seconds. You turn the robot by 90 degrees to the right, then move forward again, then stop. This is a simple task. You can do the. I think everyone should try to code that one to make it work this way. That's the first task. Why is it? Okay, there's I put another challenge activity here. If you think the first one is simple enough to finish it very quickly, you can do this challenge. So you need to create a driver pattern. Okay. So here the pattern you can define the pattern. What's the pattern? You either use a square, okay, or triangle pattern. You can do then you use a block to control the robot to follow that pattern. This one you see here, if you add a build a course with cones or lines, then you need to you put it, if for if for square you put the 4 corners at cones at 4 corners. Okay, then
Hey, Charles, sorry to interrupt you. Are you sharing a different screen? We don't see cones on the screen.
Oh, no. I mean, I just take an example. If you do a square, you have 4 corners of a square. You just put 4 subjects there. Then you need to code your robot precisely. Don't hit the cone just by running the distance or the speed, the time to not hit the cone.
Yeah, we understand. You're still showing the kind of coding screen. Is that
Yes,
what you point? Okay, I
Oh,
just want to make sure you are sharing the screen you want to share. Because you're
okay,
talking
sure.
about cones, we don't see cones on the screen.
Yeah, I see now. Oh, still see the code. Okay, I see. Can you see the PowerPoint slide now? The
No,
challenge activity one. Okay.
no.
No?
No, I don't think
No.
so.
Okay. Let me try again.
Yeah, if you have multiple screens, you choose one screen to share and just bring everything to that screen monitor. Yeah, that's why.
Because I have the laptop and the connector are external screen. Then
Yeah, when you share, you can just choose the external screen or the second monitor.
yeah, is it good now?
No, it's still the code. Probably you
Still
want
code?
to stop sharing and then reshare.
Is it working? No. No. Let me try again. Screen two. Where? Is this one?
Did you click on share? Sometimes if you don't click on share, it will not share the screen.
I did.
Yeah.
Let me
Yeah.
stop share first.
Yeah, now you stop the share. You first click on share button, right, on the bottom of the Zoom window, and then you choose your monitor. If you choose your application, it will only share the application. That's a common problem. So you need to choose your monitor and then click on the share button again to confirm the monitor you want to share.
Yeah.
Yeah, now we're seeing your slide. If you go to the presenter view or full screen, yeah, we should be able to see it. I think this
Okay.
is the screen you want to share, right?
Yes, the challenge activity one.
Yeah,
So-
now we see challenge activity. Yeah.
Okay. So we will do a drawing with a pattern. So either you square or triangle. Okay, but you can do it fast if you very you know the speed, you know the angle control very well. Okay, you can so you time your robot. So the challenge here is you need to put some cone objects there. You navigate through the course, but don't hit any objects. Okay. Here you just drive around with the speed, angle, control, distance. You don't have any sensor. Don't use any sensor in this challenge. There's another challenge to incorporate some math. So if you do a driver 360-degree circle, you can do something like this to calculate the distance. So you can use the speed times the time to calculate the distance. So that's another way you can learn math and the coding together. Here has some simple troubleshooting tips. So if the robot not moving, typically you check the battery first. Okay. Then you check the model so it's connected correctly. Then you check whether code have error. So you always check the hardware error first, then you check the software, the code. This one a little bit I'm not sure we will say this one, the drifting. So you need the alignment there. If we have two models, you need both working at the same power level. So this is just the first one. Then I will go over before I go to the Chem 2 material. Do anyone have questions? Okay. We can continue with the Chem 2. This is the topic is about playing with the objects. So it's tells how the robots interact with different objects. This is typically the when you do a FAR game, that's the different missions is you need to play with the different objects. So what kind of thing they want to do? You can push the objects, you can pull it, you can lift it up, you can grab and drop. Okay, that's a typical type of the interaction with the objects. So we need to learn how to use the code to control those, and we need to control those things reliably. Reliable means you do the success one time, the second time also success, and the third time still works. Okay, it need to be reliable. Even you change the mat, change the position, you still should be able to finish the task. Next. So there's some sample pictures for the attachment, robot attachment to work with the objects. So I grabbed it from the internet. So you can see there's a tons of different variations how to build attachments to finish a task. The common things like the arm, okay. Arm typically you can lift the lift things or grab things, arm. And you have scoop. You just put grab a object and carry it around, scoop. Then you have a clamp. Or everything is kind of doing to deal with the objects. Just a different kind of form of the attachment. So you build it by Lego pieces. Then you have lifter. The product graph here is you may see some objects may have not multiple functions to do both grab and lift. I think maybe you can the picture doesn't look right looks small in my laptop. This one, look at this one, the lower left, I think they have a arm and they have a lift going up, down. So those kind of things we need to, given our mission, we need to design those kind of attachments to handle the mission, to finish the mission. So any questions for this thing? I think this one is even it's a little more complicated than the first one, the drive around. But you say we need to build our own attachment to deal with the objects. So we need to be creative to make things work, to grab, to Okay, now it's the second practice to play with the objects. So here I put the simple one here. You just you need to push a cube into a goal zone and put it back. When you do push, you don't need anything. Just maybe just use the robot to drive the cube forward. Then it's a push. But if you need a pull, then you need an arm to. If you remember the video, you need to have an arm to touch the or grab the block, then put it back. Okay, you see here, as I said, you just use the front of your robot for pushing. You need something like a hook or a drag bar for pulling. And you need to run it consistently for 3 times. That's the, I think you can practice, you can find some legal basis to build, to test. Then maybe tomorrow, you can use your computer to test on the robot. There's the general design and the programming considerations for the robot design and the programming. Okay, you may read a little bit. This mechanical concept is a little bit, maybe you will learn along the way when you play with the robots. Okay. Also, the hard model, how to work with the model. You have a different size of model, how to control the motion, how to do those arm control. And we have a lot of different type of sensors. You have color sensor, touch sensor, gyro. I think gyro, Coach Feifei talked about gyro for a few times. It's an important feature and a very useful sensor there. I myself not familiar with those things, but I just leave list here for your reference. Maybe we can, when we get more familiar, we will understand those concepts very well and learn how to use this. There are also some challenging activity for the camera 2. One's lifting. So you need to lift a block and place it in another place, a shelf. Or a shelf you just put somewhere above some certain level. So you need an arm with a heel. Here's the give tips. You need a stable. You need if you cannot lift the robot itself should have enough weight to lift the weight less than that robot. Otherwise, you cannot lift it up. So and you need a stable robot to do it consistently. Yeah, lifting. I think it does not sound easy like it says. You need maybe a lot of practice. In the video, it's quite easy, but if you build a thing from scratch, it's not that easy. You need to find things that can lift, can grab, and can lift. There's another activity for grab and drop. Okay. This one just like it says, just grab an object and drop, carry it and drop to in another place. It gives some ideas that you can use the rubber bands. I think the the kids just try to do the hands-on workshop, the challenging one, and this is for the one who had the prior experience and can finish that hands-on project easily. You can try the challenge activities. What else? So the key takeaways, everyone need to understand the components of Spike Prime. The robot need to understand the models, how to connect all those things together, and how to use different sensors. And you need to know how to use the block code to control the movement of the robot. So the programming, everyone need to understand the basically programming how to control the movement. So then we have 2 hands-on projects to do a simple driving. Also some pushing out with the objects. That's 2 hands-on projects. You need to know when you see a mission, you need to know what kind of thing attachment you need to build to do the job. Okay, you need to keep testing and improve your design. The code and the attachment, the need to work together to finish the mission. Sometimes we need to remember that a simple equal reliable. That means if you put the attachment too complex, you have a lot of Lego pieces together to do some fancy stuff, but maybe they will break up quickly. So if you can do a simple structure, probably it will last you longer. Will give you a consistent result. So that's what simple and equals reliable here means. Yeah, there's a few questions and feedbacks you can think about. What's the hardest part to drive the robot? Okay. So any issue with the I assume everyone already know how to build a robot now for without that attachment. So do you guys meet any problem with the robot setup or the programming? Everyone tried to use the code to control the robot, right? For now. Let me see. This homework just as I put in earlier. You do the drive around and playing with objects. So you practice at home, doing some code, then test on the robot tomorrow when you have the practice there. Yeah, that's the material here. So any questions or any?
Thank you, Coach Charles. You will be sharing this presentation deck with our kids, right?
Yeah, it's in the shared drive. You guys use shared drive? I think everyone have it, right? Let me show you, please.
Sounds good. Yeah, tomorrow we can all print up during the in-person hands-on session, and we can follow the instructions Coach Charles laid out for us to finish our exercises.
Let me share. Let me share the our shared team drive. Maybe that's helpful, right? I think you see the screen, this folder, the team 7125 folder. I think every parent maybe just help them the kids access this folder. The folder is initially set up by the Feifei, and we may all work on it to add stuff. The PowerPoint I put here is here. It's a Spike Prime sets 1 and 2.
Yeah, I think you have already shared the link in the group chat. Maybe everyone should work with their parents to request access if they still have not done that. And then, yeah, at home or during the in-person session, we can validate the access for everyone if needed.
Okay.
Yeah, everyone, please work with your parents to have give a try to the link Coach Charles just shared in the chat. Also, he did the same thing in the WeChat group, which you may find from previously to request access if you still have not done that. Yeah, thank you, Coach Charles.
Thank you.
Jaden, to answer your question, you need to request the access with the email you want to use. Maybe you do not have an email yet, so work with your parents to have them
Jaden Bai,
request access.
which Jaden? I see Jaden's the Bai phone have the access. I think last time he tried, and Rinsai have access. Any else? If you request, I think the admins we can grant you access once you do the click the button. Yes. Yeah, click on link and then request access. Okay. Yeah.
And tomorrow we will have Li Jing and Fei Fei hosting 2 sessions. I think they will be posting the meeting time in the group chat. So follow up.
Yes, tomorrow afternoon after dinner.
So 6 to 8.
Yeah, I think maybe 6:30 to 8.
Okay, sounds good. If you can remind everyone in the group chat, that would be helpful.
Okay.
Thank you. Yeah, also if Li Jing, if you share your time with the group as well, that will help.
Yes, I agree with 6:30 to 8.
Cool. And if we want, we can do the same thing as we did last time. Use Jielong to sign up for a group to join each host. Since we are still in pre-season, there's no defined way of having 2 groups to go together yet, because you know, half of the team are still on vacation or out of the country, which made it very difficult for everyone to join together. So if we just use the same method we used before in the group chat to sign up to join each host session, that should be working for now. All right. If you have other suggestions, please share or follow up in the group chat. Thank you, Coach Charles. Does anyone have any other questions? Fei Fei and Li Jing, do you have any other suggestions from the host perspective?
No, we're good. Just trying to see maybe we can balance a little bit for each group. So, like for each group, maybe 4-5 kids. So when you were when you join the group chat, we maybe balance out, go to the closed one, the location close to your home. So just try to balance out the group so everybody have enough time to operate.
That's a good idea. Yeah. So I think everyone has the host address. If not, you can ask the host to figure out how far it is from your home. And when you sign up, please take a look at both lists to see which one have more vacancy. So sign up to the one or prioritize the sign up to the one that have more vacancies. Niangao, do you have anything else to add?
No, I have the sets from Charles, and my home is close by the Marvin Elementary, close to like 10 minutes to Valentine. So I think the Valentine kids can come to my home.
Sounds good. Thanks for sharing. For the two exercises, they are both great. Try our best to go through each one of them at least in some shape or form. You are not expected to finish everything to 100% because again, we are still pre-season. We don't know the mission China this year, so some of the activities may not be feasible, right? Like if you are asked to grab a coal to drop into some bucket, we know how to do it. But since there's no coal yet, there's no bucket yet, right? So we need to use our imagination to kind of work on the exercises. But that's okay. You know, we are just get to know the basics, right? Try to play with the robotic pieces and come up with a design and code it out. So if we can
David.
finish, yeah, go ahead, Charles.
Yeah, can tomorrow maybe someone while practice coding, I think some kids practice how to build some grab arm, the thing. Anyone have some prior experience, so they will show other kids how to build a arm thing.
Yeah, that would be a great suggestion. I think last session, Fifi presented some robotic design around, you know, how to build different robots and different attachments. We should definitely try that in tomorrow's session. And then based on the different attachment design, we can try to code it out to make it move, make the move and, you know, do the job we need.
Yeah, I think Natalie and Vivian, they both built all those attachments before. So I think there are few common one Natalie mentioned in the last session. So maybe we can start doing some of those. And I think Natalie, I'm not sure if Natalie shared her presentation or not, but because I think she shared a few YouTube channel to introduce all those attachments. So there'll be some good experience there.
That will be extremely helpful.
Yeah, now that you can do it in person, if I think I'll ask her to send out the presentation she did yesterday. It's very helpful for attachment. Vivian also can share her presentation, but that's just for robot build.
Sounds good. Yeah, please also share whether they will be joining which session So maybe kids who want to learn from them can join the same session if there's availability. All right. Great. Charles, do you have anything else to add?
No. Yeah, that's all I have today.
Okay, thank you so much. And for kids who will be joining either sessions, please try your best to get as much hands-on as possible. The whole idea of having an in-person session is to work with other kids, to try things out, right? You know, you are not expected to be only the observer or doing only one thing, right? You should try a little bit of everything, even though, you know, we all have our personal preference, what we want to work on. But give yourself a try, and you may figure out, you know, the hidden talent you have, right? And second, I suggest, you know, let's try to document some of the efforts we made, either by taking some pictures or doing a video of the robot run you finished, right? We will be using some of those evidence to showcase our team efforts. So work with your host, work with your coaches to get those things documented. It does not have to be exhaustive, but try to do a little bit of, you know, note taking or, you know, video recording or picture taking will go a long way.
Yeah,
those
we
are
now
just some
have
of
the
my suggestions.
YouTube channel, so feel free to take some videos if you find something cool. Take some video, and then we can start editing and post on our channel.
Exactly, yeah. So starting next week, I will be organizing and you know, working with other volunteering parents to upload our working sessions and this training sessions into our YouTube channel. I'll create a playlist called a pre-season, and we'll have coding training. We'll have, you know, the team show and tell, knowledge sharing, right? The rubrics walkthrough and all that. So it will be organized very nicely on our channel. And all these hands-on sessions, I want to make sure we can document them as well. More like a robot dry run, you know, design, brainstorming session, you know, you name it, right? The kids, you know, you are the people who will be doing most of the heavy lifting. So you need to think about how you want to demonstrate your efforts. So think about how we organize all this evidence in future sessions and around, you know, these different social media or streaming platforms we stood up. All right. And once you finish exercise, try to take a video of the robotic movements to navigate to finish the challenge. That will be a great showcase for yourself. And that will be something that we can build on top of when we get to the real challenge, which will be even more difficult, require more steps to finish and so on. But we will do it incrementally as we go. Alrighty, I think I shared more than enough. Thanks everyone for your time. Thanks Coach Charles again, and Fei Fei for sharing their own experience and suggestions. I'll see you tomorrow. Have a great rest of the evening, everyone.
Thank you.
Thank you.
Okay.
Bye.
Bye.
Bye.